class. So we are doing 2.2, and it says 2.1 day 2, but it's actually 2.2, multiplication of complex numbers, okay? So I'll just get right into it. First off, complex numbers, which you've already learned from the last video, are such that when you're taking the square root of a negative number, okay? And when you take the square root of, like, say, -4, you found out that is 2i, because that can be split up as -1 times 4, and the square root of -1 is I, and that's 2. And so every complex number can be written in the form a plus bi, where you got the real part and the imaginary part, okay? Just in general, let's talk about powers of I. So if I think about I to the 0 power, well, anything to the 0 power, if you look at up on my left whiteboard, I've got a bunch of powers of different numbers, and they all start out with like 2 to the 0, 3 to the 0, 4 to the 0. Each of these is 1, so anytime you raise something to the 0 power, you get 1. Okay? And then if I were to raise I to the 1st power, well, 2 to the 1st is just 2. It is what it is, so that is I. If I were to square it, though, so I times I, which is I squared, is the same thing as square root of -1 times the square root of -1, or the square root of -1 squared, which is in fact just -1, okay? And then I cubed is, you can think of it as I times I times I, or you can think of it as I squared times I, and we just found out that I squared is -1, so it's -1 times I, which is just a -I, okay? Now if I try I to the 4th, so that's I to the 4th is I times I times I times I, and you can think of this in multiple ways. You can think of it as I cubed times I, which is -I times I, which is -I squared, and we just found out that I squared is -1, so it's a -1, which is 1. Or you can think of it as I squared times I squared, which is -1 times -1, which is 1. Either way, or any of the multiple ways you get down to just 1, okay? So if I raise I to the 5th power, then I'm basically saying I to the 4th times another I. Well, 1 times another I is just I. And then I to the 6th is just I times I to the 5th times another I, and I times I is I squared, which is -1. And I to the 7th is just I to the 6th times another I, so -1 times I is another -I. And so you see that you create this pattern, right? So if I asked you, what is I to the 10th power? You could go ahead and count 7, 8, 9, 10, it would be -1. Or you could say, it's a pattern of 4, right? So how many times does 4 go into 10? 4 goes into 10 twice, with 2 remaining. So I to the 10th is the same thing as I squared, which is -1. So if you just, since the pattern is every 4, then you can just really figure it out by what remainder you have left when you divide. So I to the 17th. What I'm going to do is I'm going to say, well, how many times 4 go into 17? 4 times 4 is 16, remainder 1. So that's the same thing as I to the 1st, which is just I. And we can count that out: 10, 11, 12, 13, 14, 15, 16, 17. So I to the 17th is the same thing as I to the 1st. Okay? So then if I need to figure out what I to the 238th is, well, then 4 goes into 238, and I do expect you to do long division on your homework. I don't expect you to use your calculator, and I expect to see this, okay? 4 goes into 23, let's see. 5 times 4 is 20, bring down the 3. 4 times 9 is 36 with a remainder of 2, so that's the same thing as I squared, which is -1. Okay? And so whenever I want to figure out the power of I really just have to remember that it's a pattern of 4, and if I can remember these just by figuring it out, anything to the 0 power is 1, anything to the 1st is itself, I squared is just the square root of negative 1 squared, which is negative 1. And then I cubed is I squared times I, so negative 1 times I is negative I. Okay? That's something you'll have to memorize, but if you can develop it, then it's not so bad. Right. So, as far as like multiplying complex numbers, you really just distribute in the same way, but you can only combine certain terms, imaginary with imaginary, real with real. So when I multiply 11i times negative 2, I mean, I can still multiply. It's just kind of like saying 11x times a negative 2. That's just negative 22x. Well, this is negative 22i. Okay? When I'm multiplying 5i times negative 2i, I multiply the 5 times the negative 2, which is negative 10, and then I times I is I squared, but I squared is a negative 1, right? So this just becomes a positive 10, because I'm multiplying a negative 10 times a negative 1. 2i times 3i, so again, I just multiply these two together, and I say 2 times 3 is 6. And then I times I is I squared, but I squared is a negative 1, so it just basically becomes negative 6. And then negative 3i times 4i would be negative 3 times 4, which is negative 12. And then I times I is I squared, but I squared is just negative 1, so that's a positive 12. Okay. So in general, when I multiply two imaginary numbers, negative 3 times 4, I just think negative 12, so positive 12. Positive 6, so negative 6. Negative 10, so positive 10. And I just go the opposite. Okay? So here we're going to distribute. 3i times negative 5 is going to be a negative 15i. And then 3i times 2i is going to be 6i squared. And I'm going to go ahead and write that here because I know a little bit more about what I'm doing, and I know that that is going to become my real part. It's going to become negative 6 minus 15i. And I want your answer in real and then imaginary. I want it in the form a plus or minus bi. Okay? So if you wrote it down negative 15i plus 6i squared, well then I would expect you to rewrite it in terms, or with the negative 6 first. Okay? So now let's distribute the bottom one. So now I've got a binomial times a binomial, so I'm going to multiply 4 times negative 1. That is negative 4. And then we've got 4 times negative 2i, that's a negative 8i, so I'm just tagging on the I. And then we distribute 3i. 3 times negative 1 is a negative 3i. And 3i times a negative 2i is a negative 6i squared, which is just negative 6 times negative 1, which is positive 6. So now we combine like terms. Real with real, negative 4 plus 6 is a positive 2, and imaginary with imaginary, so negative 11i. And there you go. Alright, so just I'd like you to go ahead and just press pause for a second and write these two down, and at least try and find these, and then catch up and see if, or then press play again and see if you get the same thing. You should have gotten 21 I squared, which is negative 1. So negative 21. And on this one you should have gotten 8 plus 10i minus 12i minus 15i squared, or plus 15. So 8 plus 15 is 23, and then 10 minus 12i is negative 2i. And there you go. Now on the one below it, so this one I've got a binomial times a binomial with an I out in the front. So you can do this one of two ways. You can either distribute the I to one of these. You can't distribute it to both. Okay? You never distribute, like if I said 2 times 3 times 7, I would hope that you would only say 6 times 7, which is 42, Not 2 times 3 times 2 times 7, 6 times 14, because that's not what it is. That would be an extra 2. So I could distribute the I to this one, and which I'll do over here. I times 5 plus 2I times negative 6 plus I. So you could say 5I, and then I times 2I is 2I squared, which is a negative 2. And you could leave it like that. Please don't write positive 2I squared and then keep distributing and then have I cubes. Every time you have I squared, you should replace it with a negative 1. Now, if you want to make it easier on yourself, then you would rewrite it like this, but it really doesn't matter. I guess I don't need to say easier on yourself, but in order of terms, what you're used to. So that's one way to do it. Well, I'll go ahead and do it real quick. Well, here's what I would probably do. I would write I times, and then I would just distribute. So I'd write negative 30 plus 5I minus 12I. 2I times I is 2I squared, which is a negative 2. And so I would say negative 32 minus 7I. Combining the negative 30 and the negative 2 and the 5I minus 12I. And then I, and then I would distribute I. So that's a negative 32I and a negative 7I squared, which becomes just a positive 7. Which same thing I get when I do this. 12 minus 2I minus 30I. And that is 5I times I, which is 5I squared, which is minus 5. So that is 7 minus 32I. Okay, so either way you get that. So from here on out, it's just more of the same as far as like we're multiplying, but then making sure that you understand the order of operations and that you don't goof that up, I guess. So on this one, it says the quantity 2 times the quantity negative 4 plus 5I minus 5 times the quantity 6 plus 10I all being squared. So like this is all being squared, and I can't actually square it until I've simplified the inside. So I'm going to go ahead and distribute and think of it like this. Negative 8 plus 10I minus 30 minus 50I squared. And then I can combine like terms in the interior. Negative 8 minus 30 is a negative 38, and that is a negative 40I. Now we're squaring that, so that means multiplying negative 38 minus 40I times negative 38 minus 40I. Oof, 38 times 38. Let's see, 64, 24, so 30, 24. So then 9, 10, 11. So negative 38 times negative 38 is 1,444. Negative 38 times 40 is 1444 plus 2 more 38s, because it's 38 times 40 versus 38 times 38. And 38 plus 38 is 76. Yeah? 38 plus 38, yeah. Okay, so that's 10, 8, 12, 5, 1,520. So negative 1,520I. And then when I multiply that, I get a positive. Oh no, I'm supposed to get a positive there. That time, negative times a negative is positive, and then I get a positive 1,520I again. And then I get negative 40I times negative 40I. So a negative 40 times a negative 40 is a positive 40 times 40. 1,600. So it's a positive 1,600 I squared, but then remember I squared is a negative 1. So it's actually minus 1,600. So 1444 minus 1,600 is 156, negative 156, plus 3,040I. I'm pretty sure, and if my math is wrong, feel free to correct me. Okay, on this one, it says negative 7 plus 2I squared times 5 minus I. Okay, one thing you cannot do is just distribute the square. I see a lot of people do that, like, oh, that's a positive 49 and that's 4i squared, so negative 4. That is not how you do that. When you square something, you multiply it times itself. Negative 7 plus 2i times negative 7 plus 2i, and then times 5 minus I. So what we need to do is simplify these two and then multiply by that, or multiply these two and then multiply by that. But I'll just go ahead and do this. Negative 7 times negative 7 is positive 49. Negative 7 times 2i is negative 14i. Again, 2i times negative 7 is negative 14i, and 2i times 2i is positive 4i squared, which is a negative 4. So I've got 45 minus 28i times 5 minus I. And now I distribute that. 45 times 5. So 45 times 5 is 225. Yeah? Yeah, that makes sense. 225. 45 times negative I is negative 45i. 28i, negative 28i times 5. So 28 times 5. Let's see, 5 times 20 is 5 times 2. So 140. Yeah. Okay. So 140, but it's negative, so negative 140i. And then negative 28i times a negative I. Oops, sorry. I couldn't see what I was doing. Negative 28i times a negative I is a positive 28i squared, which is a negative 28. Okay. So 225 minus 28 is 197. Yeah. Minus 185i. Okay? Don't be afraid of big numbers. Okay. So this is where it gets a little bit more interesting. It's saying verify that these are the solutions to this quadratic equation. So what I'm saying is that if x equals negative 1 plus 2i, and I plug it in there, then I should get 0. So let's try that. Negative 1 plus 2i squared plus 2 times negative 1 plus 2i plus 5 equals 0. So I should get 0 if this is a solution to that quadratic equation. So I'm just replacing negative 1 plus 2i for every x. So I've got negative 1 plus 2i times negative 1 plus 2i, because I'm squaring. So that is positive 1 minus 2i, negative 1 times 2i. 2i times negative 1, now I'm distributing 2i, is a negative 2i again. And then 2i times 2i is a positive 4i squared, which is a negative 4. And then I get minus 2 plus 4i plus 5 equals 0. And let's see if that makes sense. So I get, just combining like terms, I've got 1 minus 4 minus 2 plus 5. 1 plus 5 is 6. Negative 4 minus 2 is negative 6. So I've got, those cancel each other out. And then I've got negative 2i and negative 2i and a positive 4i, and those cancel each other out. So it is true. 0 equals 0. Well, so then if I try the same thing with negative 1 minus 2i, negative 1 minus 2i, I should get 0 as well. So if I distribute negative 1 minus 2i times negative 1 minus 2i, that's positive 1. Negative 1 times negative 2i is a positive 2i. Negative 2i times a negative 1 is a positive 2i. Negative 2i times negative 2i is a positive, so negative 2 times negative 2 is a positive 4. I times I is I squared, so it's 4i squared, which is negative 4. And then distribute. So 2 times negative 1 is negative 2. 2 times negative 2i is a negative 4i. And then plus 5. So let's combine like terms. 2i plus 2i minus 4i. We'll cancel each other out. And again, 1 minus 6 plus 5 is 0. So they are both solutions. And it did say verify, so I kind of knew, I mean, we knew that was going to happen, but the question is why. So, I don't know if you remember, but there's a little thing called a quadratic formula. Where you're solving the, plus c equals 0. You're solving this quadratic equation. In our case, a is 1, b is 2, and c is 5. So if I were to fill it in, x equals negative b, or opposite b, so negative 2, plus and minus the square root of b squared, which is 2 squared, minus 4 times a, which is 1, times c, which is 5, all over 2 times a, which is 1. I get 4 minus 20, because it's 4 times 1 times 5, so that's 20. 4 minus 20 is a negative 16, so I've got negative 2 plus and minus the square root of negative 16 all over 2. So this is negative 2 plus and minus the square root of 16 is 4, and with a negative, that becomes an I all over 2. And if I simplify each of these terms by 2, I get a negative 1, a 2, and a 1, which is negative 1 plus and minus 2i. So both of these are solutions to this quadratic equation. Now, when I say verify their solutions, I mean for you to do it this method. You can check using this, but I want you to use this method. This employs your multiplication. It is true that if one is the solution, so is the other, because there's no way that you can have just one imaginary solution. You have to have the conjugate pair. And you get that from the plus minus. Okay? So one more. We need to evaluate. Now, it doesn't say prove that this is a solution, which leads me to believe that it's probably not, and I'm just going to be simplifying. So, let's just go ahead and do this. I've got negative 5x squared plus 4x plus 11, and I've got 4 minus 3i divided by 2 is x. I just want to see what happens. So I've got negative 5 times 4 minus 3i over 2 squared plus 4 times 4 minus 3i over 2 plus 11. And I just want to see what this simplifies to. So there's a couple things that you want to do. First, you want to talk about just a fraction being squared. If I were to square 2/3, that means to multiply 2 over 3 times 2 over 3, and we multiply fractions, we multiply straight across, so 4 over 9, which is the same thing as just distributing the square, which we can do when you're multiplying or dividing. So when I have 4 minus 3i squared, I'm really just saying 4 minus 3i squared over 2 squared, which I'm going to go ahead and separate this. Okay? If I said 3 times 4/5, that's the same thing as saying 3 over 5 times 4. So I just move this to the denominator of the 3 as opposed to the 4. So 2 squared is 4. So I'm going to rewrite this as negative 5 over 4. So that's just that. And then I'm going to multiply 4 minus 3i times 4 minus 3i. So that's the squared part. This right here, I'll come back to that in a second. I've got 4 times this divided by 2. When you multiply, if I were to multiply 4 times 7 over 2, that's 28 halves, or just 14, which I could figure out by just saying 4 divided by 2 is 2, and 2 times 7 is 14. So I'm going to simplify first. 4 divided by 2 is 2, so I'm really just saying plus 2 times 4 minus 3i, and then plus 11. So I'm going to distribute here. 4 times 4 is 16. 4 times negative 3i is negative 12i. Negative 3i times 4 is negative 12i. And negative 3i times negative 3i is a positive 9i squared, which is a negative 9. 16 minus 9 is 7, and that's a negative 24i. All times a negative 5 over 4. This is simplified down to negative 5 over 4 times 7 is negative 35 fourths, and negative 5 over 4 times negative 24i. So I've got a negative 5 over 4 times a negative 24i. So first off, a negative times a negative is a positive. 24 divided by 4 is 6, so I'm really just saying 5 times 6i, which is 30i. Okay? Then I distribute this and I get plus 8 minus 6i and then plus 11. Okay, now we just need to combine like terms. So the easy is 30 minus 6i, that's 24i. Now I've got negative 35 over 4 plus 19. Yeah, 8 plus 11. So then let's find a common denominator, because that's the only way we can add fractions. So the common denominator is going to have to be 4. So I'm going to multiply top and bottom of 19 over 1 times 4. 19 times 4 is 10 times 4 plus 9 plus 4, so that's 40 plus 36, or 76. And 76 minus 35 is 41, so 41 fourths. That's 24i. Okay. I expect you to do all of this without a calculator. You can check with a calculator, but I expect you to try it without, okay? And that is what you need for multiplication. And once you're done watching this video and taking your notes, I will expect to see your notes when I come back. Then you can grab the homework and work on that.